Around 700 BC, Babylonian astronomers were doing something no civilization had done before. They were not just observing the sky. They were predicting it, using mathematical models to calculate where planets would be weeks and months in the future. They built the first systematic star catalogs, recording planetary positions over decades, identifying cycles, extracting patterns. They discovered the Saros cycle, the 18-year pattern governing eclipses, and used it to predict lunar eclipses centuries in advance. The Yale Babylonian collection holds a clay tablet that stops mathematicians in their tracks. Tablet YBC 7289 contains the square root of 2 calculated to 6 decimal places, 1.4142136. This was achieved around 1800 BC, using an iterative method so efficient it is still used in modern computing. The Babylonian method for square roots works by making an initial guess, then repeatedly improving it using a simple formula. Each step gets closer to the true answer. This is an algorithm, a step-by-step mathematical procedure. Babylonian mathematicians invented algorithmic thinking. Babylonian star catalogs tracked the positions of Jupiter, Saturn, Mars, Venus, and Mercury over centuries. The data was so extensive and precise that modern astronomers have used it to verify their calculations of historical planetary positions and eclipse dates. In 136 BC, Babylonian astronomers predicted a lunar eclipse to within hours of its actual occurrence, using pure mathematics applied to centuries of observational data. No telescope. No calculus. Just an algorithm applied systematically to a pattern in numbers. Babylonian mathematics extended beyond astronomy. They solved problems we would now express as quadratic equations, finding unknown quantities given known relationships. Their method, completing the square, is still taught in school algebra today, though students rarely know its origin. Completing the square, the technique for solving quadratic equations, was first developed in Babylon around 1800 BC. The Babylonians had no algebraic notation, no variables, no equal signs. They worked entirely in words and numbers. Yet the mathematics was identical to what students learn today. Babylon was, for centuries, the intellectual capital of the ancient world. Its mathematical tradition was continuous and cumulative, each generation of scribes building on the tablets of the previous one. This is what made Babylonian mathematics so powerful: it had institutional memory. The Babylonian approach to knowledge was fundamentally modern. Observe. Record. Find the pattern. Build a model. Test the prediction. Refine. This is the scientific method, applied systematically 2,000 years before it was formally described by anyone. The Babylonian square root algorithm is mathematically identical to the Newton-Raphson method used in modern computing. When a computer calculates a square root, it uses an iterative refinement process, the same logical structure as those clay tablet calculations from 1800 BC. Modern astronomers have validated Babylonian eclipse records against independently computed historical data. The predictions match. The observations were accurate. Across 27 centuries of time, the mathematics still holds. That is a remarkable statement about the power of systematic thought. From a clay tablet iterating toward the square root of 2 in ancient Babylon, to the astronomical models that Greek scientists inherited and extended, to Islamic scholars who preserved and advanced this tradition, to Newton's calculus, to the algorithms running on every computer today. Babylonian logic never stopped computing. I am Takku. The Babylonians carved algorithms into clay 4,000 years ago. Today, your devices follow those same ancient patterns. Curiosity itself is humanity's first algorithm, seeking truth across the ages. Until we meet again, keep asking why.